Okay, so today we are going to figure out the horizontal forces applied to a dam wall by water, depending on the height of the water, so like the water level. So we're gonna start by drawing a dam, which is just like a top-heavy trapezoid. I hope this is focused. There we go. Okay, and so we have our top length of our dam and our bottom. We're gonna say that our dam is capital H tall. And then we have our water level, which is at H itself. Or we're gonna call the water level H. And so what we're trying to figure out are the forces that are acting on the wall in the horizontal direction. So the water's applying a pressure. So for calculation purposes, the top we're gonna say is 0, and the bottom is our dam height H, which means this water level right here is going to be the dam height minus the water height. Okay, so we know that pressure equals force times area, and so we're trying to figure out our horizontal forces. And we know that, never mind. We're gonna solve for force equals pressure times area. However, so our area is going to depend on how high our water level is. So our area is gonna constantly be changing because, if our water level's here, we're gonna have a lot smaller area than our water level up here. So we need to figure out how our water is changing. So is an equal pressure times our change, or how our area is changing. Okay, so we know that, little quickie, we know that our pressure is hydrostatic pressure, so that equals the density of our water times the mass, or times gravity, our acceleration due to gravity times our water height. And so in the area of a trapezoid is your top length plus your bottom length divided by 2. You find the average multiplied by your height, which in this case would be the dam height. However, since our height is changing because we're doing it based off of the water level, this right here is sort of like, depending what our height is, our length is different. So our length across the dam is going to be a lot larger than the length across the dam here. So we need to figure out what our length is. So if we draw a little visual representation, let me verify you can still see. Okay, drawing a little visual representation, we're trying to look at, whatever the height of our water is, what's the length across our dam. So obviously we have 0 here, the maximum height of our dam, because if you go over, then it's overflowing, and that's just goofy. And so if we look at 0, the length of our dam is T, our top part of our dam. And then at length H, at our height H, the length of our dam is B, the bottom portion of our dam, so B. And so this creates a linear relationship between the height of our water and the width we want to use to find the area of our dam. And so we know the slope formula, y equals mx plus b. And so we know x is the height of our water. We know that slope equals y2 minus y1, or x2 minus x1. And so this is going to be h comma b. And this is going to be 0 comma t. And so we're going to do pardon me, we're going to do b minus t over h minus 0, which just equals b minus t over h. And so b, lowercase b, is our y-intercept, which is going to be T. So we know that L equals B, so our slope, B over T, our change in our width over the change in our height, times our height of our water, our independent variable, plus T, or our intercept. Okay, so we know the area, let me make sure you can still see this. Yeah, okay, area is going to equal our length, which we just figured out. T over H times H plus T times our change in height, because this is constantly being changed and we want to figure out how the area changes in relation to it. And so we know that our change, so the way we're gonna figure out like the forces applied is where it's like you have little strips of constant force being applied like this. So if we integrate with relation to the area, we'll be able to figure out, what is the force at each strip, if that makes any sense. So we know that our change in force is equal to our density times our acceleration due to gravity times our height times, so this is our pressure, by the way, times our change in area, which is B minus T over H times H plus T dH. Okay, so let's simplify, first we can integrate, and then we'll simplify. So we know F equals, let's pull out our constants and distribute times H squared plus TH DH. Okay, so now we need to figure out our intervals. So what we're going to end up doing is we need to integrate from our height of our water to the bottom of our dam. So that is going to be H. So the height of our water to the bottom of our dam. Okay. And now squiggle squiggle. Force equals rho times gravity. So this is going to be plus 1 divided by 3, 1 plus 1 divided by 2. And so you have B minus T over 3H, H cubed plus T over 2, H squared